50 meters, wire out. Winch, dive super.
Go ahead, dive super.
Pass winch control to the control room.
Control pass to control room.
Co-pilot confirms control.
Copy that. Pilot, dive super. You are free to dive.
Thank you, dive super. Nav, can you bump my sonar to 80, please? All right, Andy.
Stand by one, co-pilot.
All right, you go ahead. All right, start coming down. Okay.
This is Roland Bryan, the video engineer. This is a general announcement to all those on the ship and the shore. This reminder that all audio associated with this dive today will be recorded with the archive video, as well as being streamed to the shore via the satellite and the internet. Keep that in mind as we proceed with the dive today, and enjoy the dive. Thank you.
Nav, dive super.
Go ahead.
Yeah, we are now passing control to the bridge. Keep an eye on streaming. They are going to maintain as is. Just be advised, before they begin to slow to come into auto surge and sway, they will have to make a heading change to split the wind and current. So give some time for that heading change while drifting.
Copy that.
All right. I will pass comms to Nav.
Nav has comms.
Nav has comms. Dive super going off comms.
Nice job, dive super.
Good work, Nav.
Thanks.
Okay, we are on our way to the bottom.
This is the Okeanos. We've joined the conference call. The scientists will be with you shortly.
That's a very... That's going to be everywhere, though. Okay, coming down 30 meters per minute. Winch looks good. Shiv looks good. What's up? Okay, good idea. Are your lights on, Andy? Yeah. Okay.
All right, good morning, everyone. This is the Okeanos Explorer. Today we are conducting a dive to investigate an anomaly named Cayman. This is a sonar anomaly that we are hoping is a underwater cultural heritage site. So on our ship in the back row, guiding us on today's dive, we have
Michael White, NOAA, OER, your friendly mapping lead.
This is Megan Putz, biology lead from University of Hawaii.
This is John Smith, geology lead from University of Hawaii, Oceanography Department.
Great, thank you very much. All right,
Pretty
so who do we have joining us on the line?
I understand that you have control. You can make your heading change to cut your forces and come to an easy stop if you'd like. Great, thanks. Okay, pilots. Ship's coming to an easy stop. Keep an eye on streaming.
All right.
Hi, this is Hans Van Tilburg. I'm with NOAA Sanctuaries Program. I'll be the archaeology lead. I'm here at the IRC with a number of different folks.
Go for it.
So this is Bruce Mundy. I'm with the Pacific Islands Fisheries Science Center. I'm the lone biologist here, just lurking in the background.
This is Amanda Murphy. I'm an archaeologist with the Central Identification Lab. Hi, I'm Allie Campo. I'm also an archaeologist with the Central Identification Lab.
Robert Schwimmer with NOAA, Office of National Marine Sanctuaries, West Coast region.
Dave Ball, Bureau of Ocean Energy Management, Pacific region.
This is Peter Bujakowski, archaeologist from DPA, and Rich Wills, also from DPA.
No?
This is Derek Young. I'm also with Fed's PW Accounting Agency.
All right, it sounds like we've got a full house. Thank you, everyone, for joining us this morning. Just want to make one last call for anyone to make introductions if you haven't gotten a chance to do so already.
Okay. If the current at your depth is the same as the surface, that is.
Okay, I'm going to push out a little harder then.
Okay, thank you very much. Mike, you want to tell us what we're looking at on video feed 3, please?
I can absolutely do that. Actually, Chris, I was hoping you could give us a quick introduction on how we came to run this line, our cooperation and partnership with UH and Hurl, and then I can talk a little bit about what we're looking at on the screens.
Oh, yeah.
Sure, I'd be happy to, Mike. So this is a line that we decided to run as the ship was leaving port to go up into the musician's seamounts. And the reason this line was chosen is because it runs over a number of known known objects, if you will. So the submarine I-401 and the submarine I-14, as well as the I-201, were captured on this particular swath. And what's particularly important is the I-201. And actually, the correct pronunciation is E, but I'm just going to say I for the moment that everybody's more familiar with. The I-201 is kind of an identical submarine to the one we're looking for today, and therefore we were trying to get an idea of how it would look on the Okeanos 302 multi-beam data. And so that's why we ran over it. It does show up. You can't really see it here at this magnification, but the 201 is present here. It's an extremely small anomaly, so we knew that we were looking for a very likewise small anomaly. Plus, the submarine was broken in half when it was torpedoed. Back in 1946, Hans will describe as well. So we were looking for similar types of anomalies on SWAT, and that's where we're at. This data, we had guys on the ship who were looking at the backscatter imagery, trying to find a suitable target.
Yeah, we just noticed the ship drifting astern a little bit. So if you could give us a bump forward
Fabian in Texas, who's really
ahead a little bit,
extremely helpful in analyzing multi-beam data. And he came back with a possible target that he called the Cayman anomaly. And he sort of sold us all that this had a chance. You know, of course, it can be rocks. It may be, so I hope everybody's not disappointed if we wind up with rocks. But I think his argument for the position is very, very good, and I think his target is quite reasonable for what could be the 203. And I'll leave it at that, Mike.
Great. Thank you, Chris. Yeah, so this was a line that we ran out on our way out. As Chris said, it had some other known targets in it, so we had a standard of looking at other targets in comparison. And I really wanted Chris to highlight this story because this is, of course, part of our telepresence exploration model in that the data that we acquire on ship, you know, we had some eyes on the ship. We have a live mosaicing computer on board here with some software from the University of Hawaii that helps us pinpoint shipwrecks. We sent those images offshore, as Chris has just explained, to the expert archaeologist onshore, and then of course the data and some suggested targets came back to us, and now we've ended up here. It's just a great chain of how we use telepresence and our exploration partnership in order to arrive at these targets. So what you are looking at right now is a gridded bathymetric surface, gridded at 15 meters. And as Chris has highlighted, we've had some folks on shore, Hans and Gary and Frank and a few others, kind of looking through this data. And one of the interesting things about what we're calling what Gary has named the Cayman anomaly, in that it does indeed show up in the bathymetry. It doesn't show up, it is very small relative to the other things you might be seeing in bathymetry. For example, this is likely a large boulder over here. So at either end here, what you're seeing are two red dots, and those red dots are at the beginning and end, or end and beginning, we'll see when we get down there, of the anomaly that we identified in the backscatter imagery. They are approximately, if I draw a profile here, they're approximately 130 meters apart, so about the size of the target that we would anticipate. And in addition to the bathymetry, we went ahead and we've also been looking at the backscatter. So backscatter, as folks on the shore and on the ship may or may not know, we like to think of backscatter as essentially the intensity of the sound that's returned to the ship. Harder objects tend to return more intense sound, and the softer things tend to return less intense sound. So you would like to think of softer and darker as sort of sandy and mud, and harder and brighter as sort of rock. So we are looking for very distinct, bright targets that are not very big, and we folks on shore identified this target here, what we're calling the Cayman anomaly. So if I just switch between, here's the backscatter and here's the bathymetry, for folks referenced on shore, here's what we're thinking is a big boulder over here. You can see it's relatively bright, indicating a more intense return in the backscatter imagery. Here's our distinct sonar anomaly here, again what we're calling the Cayman anomaly. Backscatter, bathymetry, backscatter, bathymetry. So today, obviously, a little bit of a gamble. That's why we call it exploration and not finding, of course. We're hoping to see something today, but it'll be revealed. And with that, I will pause, and happy to hear some comments from folks on shore.
So Hans, could you give us a little rundown of the objectives for this dive?
Sure, I'd be happy to. If the target does turn out to be what we think it could be, then it's the Japanese submarine E-203, which is actually a very rare submarine. It was quite an innovation. Right at the end of the war, there were only 8 of these laid down and only 3 really completed. These were kind of experimental, very high-speed, large submarines that the Japanese Navy had produced in response, basically, to advancements in, sonar and advancements in depth charge projectile systems. They realized their submarines had to get away very fast from the attack area and stay underwater for a longer period of time and go deeper. And certainly this Sentaka-type high-speed submarine met all those marks, although with only 3 actually being completed, it was never saw operational status during World War II. It was then captured at the end of the war, examined in Japan, and brought over as part of the small prize fleet in 1946 to Pearl Harbor for further examination. And following interest from our Russian allies to share in this technology, the prize fleet that was brought over to Pearl Harbor was taken out off the shores of Oahu and deliberately disposed, sunk by torpedo from the USS Cayman, hence the term Cayman anomaly. So this would be a new site that they would be looking at. We haven't been to this site before. And that being said, the objectives are to conduct a high-definition photo-video survey, non-invasive survey of the main wreck site. It may be that the main hull is broken away from the bow, as we've seen in several other cases, as Chris Kelly has alluded to. In order to identify the vessel, to identify the submarine, we'd be specifically looking for diagnostic features such as the retractable bow planes, the retractable anti-aircraft deck guns, even the bits on deck were retractable. The very streamlined form, the high length-to-width ratio, the small conning tower, the steel deck rather than the wooden decks as in other World War II submarines, oversized horizontal stern stabilizers. We want to conduct a full survey of the main features, and then also note any of the damage we see caused by both the torpedo, the sinking exercise, and possibly the impact with the seafloor. We'd be acoustically mapping wrecked visible sections and any off-site features to produce somewhat of a site plan of the area. We would also be looking to determine the vessel's state of deterioration, state of preservation, as in the active corrosion or, and measuring as well at the same time the temperature and salinity and dissolved oxygen on site. And as always with these underwater maritime heritage resources, we are happy to have our biology colleagues along with us because these are deep ocean reefs in essence. And generating a species list and comparing that with other such sites is an important task for us. So that's a brief overview of the objectives for today's dive.
Thanks, Hans. Does anybody else have anything to say about the dive today? Are you excited to see some rocks, John?
I think I'd rather see the target. But
Me too.
So for folks following along on shore, our depth here is approximately 840 some odd meters. So right now we're passing 500 at 30 meters a minute. We'll be on the seafloor shortly. I just wanted to show this is what our 3D sounding point cloud looks like over this target, and one of the difficulties in finding these very deep water archaeological sites, especially with the sonars we have on board, is of course it's a matter of resolution and how many soundings or how many multi-beam beams essentially we get over the tops of these targets. And as you can see here, we only have a few soundings over the top of this target, enough to make it a sonar anomaly, but not as good as some might otherwise see in some shallow water targets where you can pick out things like the mast or the cabin or even the bow and stern. So that's why these are challenging targets. Again, exploration and not finding.
Yeah, just a point, and since you had your data up there as well, you can get some artifacts that are actually show up as depressions rather than objects sticking up from the main surface. That showed that really well. So in many cases, those are artifacts of depressions, but also objects on the seafloor can actually create sort of current scours around them that'll result in those depressions as well. So I think this could be what we're seeing here. But again, we're just guessing. We're hoping a lot of the area further to the east has been examined looking for the submarine. So we're pretty sure it's not there. So this is our best hope right now.
Yeah, thank you, Chris. And we should also point out that one of the options we have today when we get down here and we identify what this anomaly is, we do have a Plan B site over to the northeast here as an alternative site. So we'll be changing gears if we get down there and it's just some rocks or mud. So we do have a contingency plan in place to explore a little bit further to the northeast here.
So, shoreside, this is video. Just to let you know, I've got the quad split modified for today's dive. It's 4 different views from the various cameras on the ROV. If this is sufficient for you, we will run with this today. If there's some alternate view you'd wish, please let me know. On to stream 3.
And also for shoreside folks, is one of the things that was requested was screenshots of the ROV CTD as we approach bottom here. CTD tells us some pretty standard oceanographic parameters, so I'll be capturing those, and if anybody would like those, they just need to contact the ship Happy to send them out.
This is Hans at the IRC. The quad shot is impressive. As long as we do have from the D2 a full screen without any sled or manipulators in the shot, that'll be important when we begin the survey if we're on the submarine itself.
Yeah, stream 1 will be the ROV HD the full time. Stream 2 will be Sirius the full time. And then stream 3 is just multiple cameras. If you want, we can put the Sirius view also in that quad split, so you can see ROV 3 cameras plus the Sirius.
Screen 1 is the full screen. Roger that. Thank you. I mentioned earlier that these were high-speed submarines, very rare, produced right at the end of the war. By high speed, these were reported to be able to do 19 knots underwater, which was pretty astounding in 1945. If I remember correctly, I don't think we had anything that could do half that speed. So that's twice as fast as anything else. I think it's probably one of the fastest submarines that have been built at that time.